Okay, well, here we are. Another stupid drain file. The complaint was water running out of the coil. Opened the cover and the pan was full. Got the piping loose. Notice I couldn't get my brush down this male adapter. Guess why? Can you believe that? That's what they chose to use as a male adapter. I don't know where this thing came from. Maybe it's supposed to be an auxiliary drain. They shipped the coil and they thought they'd be slick and not buy a 50-cent male adapter. So that's what's going back in. I'll tee off and put a plug in the end of it so it can be cleaned out in the future. This is a job that I reworked. Too much to go into about that, but you can see I added this return to this side and it's rusted that out real nice, so I'm going to try to clean that up for him. Okay, just another record for stupid installation mistakes. So that's okay, guys, got the drain taken care of. You saw the silly auxiliary port fitting they used for the main drain. Thought I'd make this nice and easy to clean in the future, so now you can just pop that cap off and run a pipe brush in there. This job, I said that I reworked this. This was all ductboard to begin with, and you see I put this trunk in below and the pipe's in the top behind that flue pipe. That was just a ductboard trunk, and it popped up out of the top of that trunk and then followed that joist bay right there and went on across and then back around the stairway and then fed the other end of the house that direction. So this was a case where guys were using 0.1 friction rate on their ductulator, and that caused them to be way off on such a large system. The equipment itself isn't that large, but it was. They oversized the furnace. I had to derate the furnace. Ended up doing a lot of work here, but so I've got those. I don't know if you can see the 10-inch pipe behind that flue. That's coming out of the top of the plenum now. It's really congested. It's hard to see. So that gets full velocity out of the blower to carry around to those very far ducts. And then I moved this down and put a damper in it. This goes out to the crawl feed that side of the house. And I've got an OG that carries that back up and into the existing ductwork that was there, and I had to change a few runs out there. But yeah, so 0.1, no good. You got to figure out friction rate. So don't assume that you can just dial it to 0.1. If you want a rule of thumb to follow, and I don't suggest following rules of thumb, but you need to have a below 0.06 on your return. You really get below that though, and you get you get ducts that are way too big and expensive. But even if you go 0.08, once you check your velocity, a lot of times you're going to be over velocity. So 0.1 is always too much velocity. Duct's too small. So this has all been changed. You'll see this. They had this one duct board return coming down, and they had two little, forget what they were, 12 by 12 duct board chases coming down to feed it. So I carried one into that existing return. There's this little filter door they did, and then I panned off the space and then made myself a nice little radius to carry it into the trunk, return drop, and another radius. And you see I've got a little mastic on there. I tried to scrub that rust off, put some mastic on it. And there's my little filter door. And so here we are. I'm getting ready to check the charge. It's pissing a little bit, so we'll see how that turns out. But maybe I'll go into some more detail on this from the office. I'll show you all the design work I did on this. I redid the flue. This reducer was in the horizontal plane. You saw the silly drain adapter. So. Well, that's it, guys. Okay, guys, I'm checking the charge on this now. It's 90 outside. And wet bulb is 70 inside. It's a piston. What I'm seeing though is a little odd. This is acting like it has an expansion valve. It's hunting the suction pressure. It's going to fall to 70 and rise to 80. And the suction line temperature stays the same. So we got just a little vibration in the discharge side, very minute. So that's, you know, I see this and I'm thinking non-condensables, and look here and it's really not vibrating or fluttering. So you see that's come up now. That's still rising. And even if it was running at 80 psi, it's still 75. It's a little too warm on the line. At 80 we should have about 68 degree line. 70 should have a 61 degree line temp. So this isn't fluctuating as wildly as it was a minute ago, but it is rising and falling between 70 and 80. If you guys ever seen that, maybe you know why it's doing that, let me know. I'm curious. I'll give you a little more heads up here. The head now, the R22 scale, it's moving up and down a little bit. Okay, it's at 120, it's falling to 120, and it's starting to fluctuate pretty good. You see the liquid line temperature is 117. Looks like we're about 118, so there's no subcooling going on. See the subcooling temperature dropping. So there is just a couple degrees, but on the superheat we're looking at about a 38 on the R22 scale, and we're looking at 73. It has come down a little bit now. Now see, watch the guy move. Okay, well, I'm going to play with the charge a little.